So as I move forward with the Z80 starter kit here, I found what I believe to be the ZBUG binary file of it, and I programmed it into 32716s. Really only needed one, but I programmed 3 parts up. And there was somebody had done a restoration and written a little bit of software for it, or maybe the software came from the manual, I'm not sure, but there's a memory test, a clock display, and a segment test for the displays up here. And again, I programmed 3 of those. This goes in the U33 slot here. But the first thing to do here is just power up, make sure the system still comes up, and it does. Hopefully you can see the 7-segment display. Let me take a look, and you can. And we can go to, 00. Why can't I enter zeros? Reset. Okay, it just needed to be reset. Do a memory exam, and we can look at an examine next. And we can look at the bytes in the ROM, which is what we're doing right now. So let's turn the power off. Let's see if we can pop out that ROM that's currently in the machine. Where's my chip puller? Why is it always such a challenge to keep tools? Be right here. There it is. Let's see if I can get this ROM up out of here without bending the leads, like so. This happens to be a National Semiconductor part here in my hand, 27C16. I'm partial to National EPROMs because I mentioned it before, I worked for National Semiconductor in the 80s when we were manufacturing parts like this 2716. I'm just noticing that the lead frame isn't centered over the packaging isn't centered over the lead frame. There's a little bit of weird offset. I don't think I've ever noticed that before. This is probably a part that was assembled in the factory in West Jordan, Utah, and not, it was, well, I don't know that. I have some parts that were, like I say, we fabbed them right there in West Jordan, Utah, and we could package there as well. So that's got the ROM image in it. Let me do a power up and hit reset. Well, we've got the cursor. Examine memory, 31, C0. So it's the same bit pattern. So that's nice. What I will do is get back on my EPROM programmer, load an image of this and just compare. But for now, I'm just going to leave that in there, since it appears to be working. Let's then take one of these parts. I don't remember which one was what manufacturer. They're probably all 450 nanosecond. There might be something here a little faster than that. But for the 2 megahertz system here, 450 is fine. So let's go ahead and power up again. Do another reset. Go to 0800, re-examine. There's definitely a bit pattern there. 0900, oops, let's see, back to the monitor, 0900, memory examine. And again, there's a pattern there. 0A00 is where the third one is. So 0A00, and let's do an execute. And I believe that's exactly that test. So you can see that it's chasing all the segments. Well, not all, but it's doing that little chase display there. That's pretty cool. So we know that we're reading this ROM here and able to execute code from it. Get back to the monitor. Let's go to 0900. This should be the clock. If I execute it, it turns the system into a digital clock. There is a way to set the time and tune this to get accurate time. But that's pretty cool. It's pretty cool that I'm actually able to put a ROM in and execute code from it. And the fact that those two just worked, I will just simply erase the other parts and put them back into my stock. 2716s are getting hard to program. I've got a couple data IOs, but I don't have access to them at the moment. I've got an old USB programmer that will actually program 2716s. It requires external power to do it. And that's what I used to program these, and the drivers for it are unsigned, and I had all the fun of installing unsigned drivers in the current build of Win10. Rolled over to 1 minute, that's pretty cool. Let's go to 0800, and this should be a memory test. Actually, I wanted to execute from there. So what it should do is test through. See it counting down here. Hopefully it's just going to test the 1K of DRAM or SRAM, then increment the bit pattern and go again. That seems much larger than that. Does not seem right. 0800. I'll have to go look at the source for this one. I thought it was just going to loop in the address space for the 1K we've got in here, but it looks like not. So let's reset. Let's set our machine to start from the first program it finds in EPROM 1. Let's do a reset, and I expect that to be the memory test, and it is. So that works. We can pick which ROM we're going to start from. It's either from, either address 0000. Well, yeah, in this EPROM or 00. It's either mapping this EPROM to address 0000 in the Z80 address space, or this one to 0000. It's interesting that flipping it back over. At least I assume that's what it's doing. No, it must have forced a restart to address 0800. Otherwise, this code would have crashed. So it's not actually mapping which ROM is in which address space. It's just somehow forcing. It's got to be just forcing a different start address on reset. But anyhow, execute. There are 3 different little programs in EPROM that all seem to do something. That's kind of cool. It verifies a little bit more the hardware is working. And I guess with that quick program, or that quick demo, I'm going to wrap this one up, and I'll see you in a future video.